Welcome to today's quick mini lesson on how to use substitution to solve for two different variables. This algebraic technique may come in particularly good use when we are attempting to calculate the percent abundance for two isotopes of the same element. So let's take a quick look at our sample problem first. We're going to write down everything that we are given, looking for and any relationships that exist that can get us from what we're given and what we're looking for. So our sample problem is a newly discovered element, AB, is found to have two isotopes, AB-138 and AB-142. If the average atomic mass is 140.84 AMUs, what is the percentage of each of the two isotopes? Alright, so as with any good problem-solving technique, the first thing we're going to write out is what we're given. First thing we're given is we have two isotopes AB-138. So AMU equals 138. Next thing we're given is 142. And lastly, we're given the average atomic mass of 140.84. We're going to say average last thing we know is that there are two isotopes. That's it, just two isotopes. Now, what are we looking for? We are looking for the percentages of each of the two isotopes. Let's change over to purple for this. So the percentages. Looking for okay. Next, we're going to take a look at any equation that might exist between all three of these. I guess it's all four of these. So we know that our equation for average atomic mass equals our mass of isotope 1. I'm going to say mass of 1 for isotope 1 multiplied by the percent abundance of isotope 1 plus the mass of isotope 2 times the percent abundance of isotope 2, etc. Now if we're going to leave these in percent form, we're going to divide these by 100 at the end. Let's see what we can plug in and where. So we know that 138 AMU goes in right here. We know that this goes down right here for mass of 2. And we know that this can plug in down here for the average atomic mass. We are looking for these two numbers. So I can put in an X and a Y. So let's start plugging these in. So our average atomic mass of 140.84, and just for the cleanliness of this, I'm going to write AMU for our units. Mass of 1 is 138 AMU times X plus 142 AMU times Y over 100. Fortunately, since this is a percentage and there's only two of them, we also know that X plus Y equals 100. Now, using substitution. We can solve for x in this equation and then plug that in for x in the above equation. So x minus y, that gives us x equals 100 minus y. Now I can plug this quantity in for that x so that we're only solving for one variable at a time. So let's take a look at what that looks like. Equals our 138 AMU times 100 minus y plus 142 AMU times y. Now we've only got one variable to worry about, over 100. Now we're going to distribute the 138. So we're going to say 138 times 100 will be 13800, and now I'm going to start to drop off the units just so that for the cleanliness of the problem. So 13800 minus 138y plus 142y over 100 equals 140.84. Now we can multiply each side by 100. Whatever you do to one side, we have to do to the other. So that gives us 140.84 equals 13800 minus 138y plus 142y. Now we can reduce these. So negative 138 plus 142 should give us a positive 4y. Equals 140.84. Now we can subtract 140.84 minus 13800 gives us 284 equals 4y. Divide 284 by 4 gives us 71%. Y should equal 71%. Remember, these are whole numbers. Now we can go back. It'll be much easier to plug 71 in for y up in this equation right here to solve for x to get our second variable. So as of right now, we know that y, which is our AB 142, equals 71%. And now we'll also know that our x, which should be AB 138, should be 29%, because 71 plus 29 equals 100. Hopefully, whoops, there we go. Hopefully that'll help. If we've got any other questions, please make sure that we reach out. Look forward to seeing everybody back in class on